Thank you all for being here today and welcome to the 2025 webinar series hosted by the Alabama Mobility and Power Research Center here at the University of Alabama. My name is Elizabeth Pettit and I serve as the Workforce Development Coordinator here at the AMP Center, and I'll be hosting today's episode. Now, whether you are here for a first time or as a longtime listener, I would like to start off by sharing a little bit about the series and introduce our lovely panelists. The goal for this series is to provide those interested in the battery manufacturing and electric vehicle industries with a general understanding of various topics such as infrastructure, mining and supply chains, workforce development, safety, economic development, and the like in the great state of Alabama in very easily digestible chunks. This episode in particular is titled Safety and Innovation in Battery Manufacturing. It explores the importance of safety standards, innovative manufacturing techniques, and ensuring the long-term reliability of batteries. Now that my long-winded introduction is over, I'd like to take a moment for the panelists to introduce themselves. If you could each share your name, affiliation, and what you or your company do, that would be greatly appreciated. We can go ahead and start with you, Bjorn.
Thank you very much. My name is Bjorn Stoll. I'm CEO and President for Degatron Power Electronics over here in the United States. Degatron is a leader in battery testing information as well as cell assembly. And I think today we want to share how advancements, particularly from our perspective, are improving performance, cost efficiency, and safety across the industry. Thank you.
All right, Nick, we can jump over to you.
Great. I'm Nick Warner. I'm the co-founder and principal of Energy Safety Response Group. Our organization helps our customers build safer batteries, get those batteries deployed for stationary and behind the meter grid support, and we help train fire services in how to respond safely to these batteries and how to manage their planned and unplanned end of life.
Wonderful, thank you. And we will jump over to you, Bob.
Well, thank you very much, Elizabeth. My name is Bob Guyon. I am the chairman of the Technical Advisory Board for the Battery Group there at the AMP Center and the University of Alabama. I'm honored to be able to do that. Over the last 6 years, I've been running a company called Guyon Energy LLC. After I retired from CATL as the Chief Technology Officer for the world's biggest battery company called CATL. And I'm honored to be a part of this group today to talk about safety.
All right, Lars, we will move over to you.
Okay, thank you, Elizabeth. First of all, my name is Lars Möller, Technical Director at InproCode. We are a coating application company, and when we apply coatings, we apply them to protect, let's say, something. And in this particular case, in 2018, we have started researching in a specific team the possibilities of apply protection coatings for battery system, which were mainly related to the individual lids that are on top of the lithium-ion battery. So that was a specific development project starting in 2018 since then. And so that's my main focus for this session today, also safety driven to protect whatever comes out of it.
Wonderful. And last but not least, we have Alec.
Thanks, Elizabeth. So my name is Alec Falzone. I am the battery industry leader for the Americas at Honeywell Process Solutions. So at Honeywell, we're a technology company, first and foremost. And specific to battery manufacturing, we have quite a few different approaches to improve the quality, the safety, reliability, and performance of the cell, the materials, and of course, the finished battery system product. So really looking forward to our discussion today.
Perfect. Thank you, everyone. As you can see, we have a wonderful group of panelists with us here today who bring a wealth of knowledge about safety and innovation in general. So without further ado, we will dive right into our questions and get rolling. First up, I have a question for you, Bob. How is your organization fostering collaboration between industry leaders, research institutions, and government agencies to accelerate innovation in battery technologies? And kind of a second part to that, what steps are being taken to ensure the safety, performance, and scalability of these technologies as demand grows?
Okay, on the first question, Elizabeth, in my past career, I was the chairman of the Battery Standards Steering Committee for SAE International. As a part of that role, I had 25 different committees that were working on various aspects of battery technology, and all of them related to safety in one way or another, but then there was one specific to safety. So that's one method of being able to participate in making sure that we have safe and effective battery products is work with professional standards organizations like SAE. We had over 850 people that were in those 25 subcommittees. So that's a fairly large group of professionals working to develop safety standards around all aspects of batteries. A second way is to work with other professional associations like the world's largest professional trade association called NatBat International. I'm still the chief technology officer for NatBat International, which is a large collaboration of people that work in all aspects of battery technology. But predominantly in that organization, it's more about commercialization and getting the word out about battery technology. In fact, within the next couple of weeks, they're having a big workshop on recycling, which has its own metrics around safety and tearing down these sophisticated battery systems and making sure people are safe as they tear down these devices. The other way I do it is through my professional consulting role in Galleon Energy, LLC. In all aspects of working with my clients, we always talk about safety. So to answer your second question that you ask, as my role as Chief Technology Officer, I learned very quickly, and Alex mentioned this during his introduction, quality is of the utmost importance because the devices that we call batteries have a fundamental building block, which we call a cell. An electrochemical cell is an active source. What we mean by an active source, it's something you can't turn off. It's too costly to build a system that you would require you or be able to turn off an individual cell. But these active sources are, after you charge them for the first time, they're like a living entity. These things are alive. They have energy in them. And the only way that you basically deplete them is completely discharge them down to nothing. Okay. So it's really important for our audience to understand that once a battery becomes an active source, it is something that can effectively have voltage. It can shock you. It can hurt you and kill you. So I think the important thing is that we build an understanding and environment of all the professionals that we've got on this call today. They can all attest that we build systems different ways and still achieve a result that these products are extremely safe. There's been no recorded incidents that I am aware of that people either didn't intentionally shock themselves or they did something silly working with a battery system that allowed them to get shocked. Such as the Tesla that I'm sitting in right now, it's impossible for me to get shocked from the battery pack system because we built several different safety measures around the entire system itself and it's installed into the vehicle. And this is no different than what we do in these giant energy storage systems in the grid network, where these battery systems are there to help support the grid infrastructure. So for our young audience that may be listening in today, there's a lot of different disciplines that we have in the battery industry, everything from electrochemical engineers to electrical engineers, software engineers, hardware engineers, process engineers, and Alex will talk a lot more about that. Nick will probably talk a lot about safety. Bjorn will be talking about, how we do the testing of these battery systems in laboratory environments and testing the life cycle characteristics and the longevity of it. So I'm sure Lars will chime in on his specific area of expertise, but I want to just make it a point that it takes a large number of different disciplines in order to build a sophisticated battery system and make it safe. So with that, I'll turn it back over to you, Elizabeth, and hopefully I answer both of your questions.
Yes, that was wonderful. And you are clearly a very, very busy man there, Bob. I've actually recently toured a battery plant here local to Tuscaloosa, and it was very interesting to see the safety measures that were built in at every single level of building and installation of those batteries into a vehicle. So I appreciate that answer there.
Well, Elizabeth, I'll tip you off to something. That plant that you went through, I helped design that battery pack system.
Wonderful. That I had no clue. That's really great. Thank you.
Okay.
Yes, we will next move over to Lars with ImproCoat. Lars, how are safety standards in battery manufacturing evolving? And what role do coatings play in ensuring both safety and performance in batteries?
Yeah, good question, I think. Of course, I have to, and I would like to simply tell the story on how we came into that topic and just to explain how ImproCoat has jumped into the topic of are coatings, specific coatings, able to improve the safety? As I've said in my introduction, all started in 2018, and it was a very generic thing for us. We simply have been asked by two big OEMs if there is an idea from our side with regards to the coating being applied within a battery system to survive a thermal propagation once it occurs, and to ensure a specific time until that thermal propagation moves through the battery lid towards possible people sitting in the car. So there was a very clear question. Why did those OEMs raise that question to us? I told you guys, we are a big applicator of coatings, and one specific topic for us is fire protection coatings, which are normally regularly used in the steel structural industry. So to protect the steel beams in a big building. And during the research of the OEMs, they found out that ImproCoat is one of the biggest applicator of those coatings in Germany, sometimes in Europe as well. So we had no answer to that question because we had no experience with those energies, the specific case of thermal propagation, temperature, pressures, particles, whatever. So we set up simple rigs, and that comes then to the question of how are standards and test methods evolving. So we built rigs ourselves, and we did flame torch tests, very, very, very simple. And we measured times, we measured temperatures and stuff like that. So over the period of time, we developed test rigs, test setups, and we developed coatings and coating systems. So when I say coatings, for us, it's not only like we spray something on top of some kind of substrate, whether it's aluminum, glass fiber, or you name it. We also, let's say, tried to set up different test methods. Over the years with the OEMs, with other applicators, standards also evolved. We had the first technical rules. We had the UL standards. I'm sure you guys also know. So it became more specific, became specified, and moved into standards. So that was a very good finding for us, because it of course makes it much easier to have comparable results once you have, let's say, applied some kind of heat on some kind of substrate. And all is related to, you measure the time until it breaches through, you measure temperatures on top of the backward surface to the incident. And so it evolved a lot. We have standards now. We can compare systems. We can compare layouts of coatings. And it's not only fire protection. So that would be my last point in the first answer to that. We also have cooling coatings. We have coatings that can improve dielectric properties of the battery. So it's many things we can do with coatings. And so that's a long story being told short, but that's how I see it. That's what we have seen, how the industry have moved into being specified within standards and specifications.
Wonderful. So, two things I love about that response. One, you mentioned that safety testing does not need to start at a very high technical level. It can be very simple, like a torch test. So, I think that is wonderful for all of our younger listeners out there to just know that you can get started in a very easy way. You don't need to be right at the top of the game instantly. And then two, you mentioned, of course, the evolving standards, which just like all the technology in this industry is very rapidly changing as well. So a very good point for our listeners to know to just stay up to date, keep your eyes peeled, and see what comes up next. Thank you so much, Lars.
Thank you.
That brings us to our next question for Bjorn over at Digatron. Bjorn, what advancements in battery manufacturing are most exciting to you, and how can these innovations improve the performance and safety of batteries?
Yeah, thank you, Elizabeth. And number one, I'm quite happy that Alabama is having this kind of a format because I believe the future workforce development is the key step for a proper manufacturing process in the future and to capture and measure potential risks during the manufacturing process. So hence doing it on university level and transfer this know-how with the educated workforce to the industry is the best and first step to start. What is exciting me is now coming from the lead acid legacy world with our products from 1968 up to today. On the lithium side, we understood safety is not it's not a bolted on device. It's like a built-in solution, and hence it is really important for us to work closely with certification bodies as well as safety partners like Honeywell to ensure compliance with evolving international standards. Secondly, for us and for the entire process of cell assembly, it is important to have a real-time monitoring of what Lars said, as well as its temperature, voltage, and current monitoring, and having automatic cutoff and alarms to ensure the operators and the products are safe during the cell assembly as well as during the formation. So hence the idea of being only an equipment manufacturer to become a full turnkey solution provider with several partners is the key for the success and for the safety of our operators, of our customers and end users of the batteries on cell level, module level, or pack level. So hence key learning and key enjoyment working now in this industry is working with several companies together to bring everyone together to ensure that we are producing high quality and safe batteries in the United States.
Wonderful. And that ties exactly into what the AMP Center does that well, of course, bringing in government, industry, educational leaders to really make sure we're steering the ship in the right direction, that we are being safe, that we're collecting all of these different points of view to make sure that we're just going in the correct way. So that is wonderful. Thank you so much, Bjorn.
Thank you.
Next, we will jump over to Alec with Honeywell, just because you mentioned them. So Alec, how can software solutions enhance the safety, monitoring, and efficiency of battery systems? And then what innovations are you most excited about?
It's a great question, Elizabeth. And Bob touched on some of the different battery systems during his portion. So if you think about the different battery systems that are all around us, I think a lot of them are taken for granted. The laptops that we're all on right now, the cars that we're in, the cell phones in our pocket, the tablets that we use when we travel or, at the work site, different toys and gadgets, our kids use or we use around the house. They're everywhere. Right. So the safety of the system starts with the components of the system. And so I'll focus on the battery cell that Bob mentioned. So it is the building block of every battery system. And so the quality, the safety, the reliability of the system starts with that cell. And it's an incredibly complex and exciting process, right, to make a cell. But I think what's most exciting to me is how that's evolved, even since I joined in the battery industry some time ago, is manufacturing now is more proactive than reactive. It's more connected. I think things are becoming more digitalized, and gives the ability to, implement things like closed loop control, feedback loops, safety interlocks, feedback and feed forward control loops, of course. And there's so many different ways to tackle that, right? So it's interfacing with many different systems as part of an ecosystem within a manufacturing plant, right? So going into manufacturing a cell, you'll have components from all different suppliers, Digatron being one of them. There's probably a few others. So when it comes to software, hardware, and sensors, the software and hardware has to be able to interface with all of these different types of data sources, right, to connect the battery process. That's something that historically has been very, I'll say, siloed. Is automation has always been part of the battery industry, but it's really been, think of it as islands of automated steps. But now with some of the integrated equipment, again, from Digatron and others, there's connectivity. So data that is generated upstream is communicated downstream and vice versa. Same thing with sensors, right? Part of the data generation is sensors, both on the safety side. I'll use the formation process as a good example. So Bob mentioned, as soon as you put energy into a cell, it's a living, hopefully not breathing thing, but it could happen. But in formation, if there's an internal defect in the cell, you would find out in formation. So the objective is to catch it as soon as possible in the manufacturing process. And that's what we as Honeywell do. We try to implement different sensors and technologies to detect manufacturing anomalies before they pose a safety risk. So it improves the safety, the quality, and the reliability of the system. So again, that goes back to being more proactive. So identifying deviations early on, implementing corrective actions, making improvements in real time, not after the fact, to ensure, the end cell that you're producing is the best cell that you can.
Wonderful. Thank you for that. I do also appreciate you bringing in kind of being proactive about safety and just other things in general to the conversation. I think that helps ease the mind of potential consumers or even our young people, just in knowing that this is not a waiting game for us, but we really are actively trying to make batteries and electric vehicles in general very safe, very good for the consumer and the public at large. Thank you. And for our very last individual question, I have kind of a big one here for you, Nick. How is your organization supporting the public safety and emergency response preparedness in battery manufacturing environments? And then a smaller second piece to that is just what strategies are being used to train these local responders?
Yeah, so it's great that I get to go last because I get to brag about everybody who went before me and then build on what they say. And for a long time, the concerns around lithium-ion battery safety centered around thermal runaway. Everybody was very concerned about single cells going into thermal runaway and causing problems. And in the world that ESRG operates in, which is really more with the finished product, whether that's a stationary energy storage system or an electric vehicle, we find that very, very rarely, in fact, if at all, with stationary storage systems, has there been some kind of large-scale safety event attributed to a single-cell thermal runaway. So the work that all of these guys have done, from ensuring high-quality components are going into the process to testing and validation methods to validate that the cells being produced are good, to sensors to detecting pending failure and ensuring that these products are resistant to it. They've done a phenomenal job, but the fire service exists because things still go wrong. And that's really where we come into it. We get to take all the great things that these guys have done and talk about, hey, how great the cell is, and then tell the fire department, but the world always builds a better idiot, or something is always going to go wrong. And so despite these best efforts, people have bad days. They connect positive and negative cables backwards, or somebody doesn't close a door well, or something leaks, somebody doesn't make a seal very well in a system, or electrical components just fail, things catch on fire. Structures have been catching on fire for thousands of years before there were ever batteries, and unfortunately things just happen. So we have all these levels of safety, but then there's an applied level that goes on top of all of that, which is, as safe as things are, how do we still manage it? And batteries are a very complicated technology, but at the end of the day, a lot of the hazards that batteries pose that people talk about with respect to the challenges in putting them out, with respect to the electrical nature, the stranded energy never really goes away. They can produce flammable and explosive gases. All these things are hazards that the fire department and industrial safety and public safety deal with on an individual basis. Batteries just kind of bring it all together. So we educate them on each of those individual challenges. When we work with our customers, so we take what we've learned from large-scale fire testing, what we've seen go wrong, what people have messed up in the field, and help them build a better product that accounts for that. We do large-scale fire testing so that we understand, hey, even though we built this thing, how is it failing? Is it failing in a graceful way as we anticipated it would? Or do we have a giant jet flame shooting out of the side of this because somebody didn't realize that this thing was going to melt? We take what we learn, we put that into hazard assessments for these different products, understand where they might fail, understand where there might still be some barriers that aren't strong in the protection of these systems when they fail. We get them permitted. We put together response plans based on what we've learned from testing, based on what we've learned from other events in the field, based on where people like Bob and Alec can tell us, hey, we think we still have some weaknesses here. We account for those. And then we train the fire department to those, and we act as a resource for the fire department. The fire department, in general, handles a wide range of hazards every day, from getting a cat down out of the tree to a motor vehicle accident to EMS runs. They can't be an expert in everything. And so it's important to have subject matter experts who are available to the fire service, who are ready to go, who know batteries. And at the end of the day, we do everything we can to review processes, review systems, train the fire department, but ultimately we're there to support them when those events do occur, and then come in and handle this technology afterwards, because it's not like going through a house fire during overhaul and looking for hot spots. The fire department doesn't have the training, they don't have the equipment, the gear to go through these batteries safely. And in a lot of cases, the people who make them don't have the experience or the equipment to go through it either. So we act in that capacity as well to ensure that through the end of life, till we put that final one on the truck for disposal, it's done so safely.
Perfect. And one of the things that I love most about ESRG is that you guys do make yourselves available for the public and for those first responders. Hear all the time, whether it's from students, other professionals in the area, our local fire responders. What do I do if there's a fire? They're very concerned about electric vehicles and batteries having fires at greater rate than an ICE engine. So just trying to really ease those tensions there, put them at ease, and just make sure that everybody knows what safe practices are, even though they are evolving and technology is evolving. So thank you so much for that.
1-833-SAFE-ESS, 24/7.
Thank you so much. For our very last question, it will be for all of our guests here today. So please feel free to jump in as necessary where you think you can add in. As safety technology becomes more advanced in battery manufacturing, what types of new jobs and training programs will be needed to support these changes?
What Nick said is absolutely important, is that we are educating our first responders in a proper way, because obviously we are giving trainings to operators and to the workforce, but first responders need to get educated as well, together with academia, with the industry, as well as with the end users. So hence, I believe fire and battery safety engineers or safety integration engineers are really a key for the future. Plus, obviously, what Alex said is software and data engineers on the safety feature side. And plus, obviously, training our field service engineers who are doing the calibration and who are doing like all kind of like necessary changes which are required to use like the systems on, I would say, like a cell agnostic level. They need to get trained and educated on a continuous level to be educated for the future developments of the individual battery manufacturers. So hence like integrating safety into like all kind of like engineering education is the key for the future to keep like our workforce educated as well as like safe.
Yeah, I think to build on that, because I have been having conversations with universities a lot lately, and I look back to my own time at a university up north I won't mention, but the way the safety curriculum was described in the MECE program was boring as heck. In fact, I avoided the safety classes there because they didn't talk about how they were applicable to reality. My safety background actually comes from nuclear engineering, and it applied well to energy storage, and learned a lot as we went. But I think when it comes to safety, it's never enough to just be educated in what it is you do. An electrical engineer is never going to adequately identify all the potential safety hazards that come from a battery, nor is a mechanical engineer, nor is a chemical engineer. They've got to have an understanding of a wider range of how the systems work, and in particular at the technician level. In a lot of cases, the technicians who might be responsible for basic maintenance on the systems are going to be the first responders to these incidents. They're going to be the ones who might be calling 911, and they're going to be the first people that the fire service interact with, and they need to understand what the fire service needs to know. It's not enough to say that, cell 6 in module 14 in container 4 is 0.2 of a volt high. What does that mean for the fire service? What is the hazard? Same thing with electric vehicles. If you work for a manufacturer and you're calling in as a fire service, hey, I've got this hazard. What do I need to do? It's not enough to know that, hey, this set point is bad. A computer can tell you that. It's tell me about where the battery is. Tell me the weather conditions. Is it raining in there? Are other things going on? Has it been down for maintenance? And as a result, a certain safety system is offline because it doesn't have power. We've got to understand how whole systems work together. It's not enough to just be able to design one component and pass it off.
I'll add on to something that Bob mentioned early in the discussion, was the multidisciplinary aspect of battery manufacturing. I think it's one of the truly, it touches on almost every technical topic in a way, right? It's a little bit chemical, it's a little bit electrical, it's a lot of bit electrochemical. There's software involved, there's electrical engineering involved, there's so many disciplines that contribute to manufacturing a battery, right? So for all the students out there, watching this, right? I mean, myself, I'm a chemist, by degree, right? And now I'm involved in manufacturing, right? So I think it's an opportunity to bring together all the different disciplines to make a safe, a quality, and a reliable battery system. One other unique aspect is, I think cell manufacturing is one of the few examples of where the building conditions directly impact the quality, the safety, and the reliability of the end product. So how dry and what temperature the building is determine how safe and reliable the end product is. So there's a lot of jobs, right, and skill sets that contribute to everything I just mentioned. So a lot of them exist today, right? If you think about an electromechanical engineer, that's a fairly common role. But I think with the battery industry, it's the need for more of them, right? So instead of that engineer being in, let's say, automotive assembling vehicles, it's the similar skill set to make a battery. I think when it comes to a local fire marshal, right? So kind of adding on to what Nick mentioned, instead of, fire safety for, a new office building, it's what are these new hazards in a battery manufacturing facility, right? So it's using some of the same approaches, just in a very fast moving, evolving field like battery.
Just a little add-on from my side, guys, because most of it has already been said, and it's complex, it's technical. We need to know the details in all the different disciplines, as Alex was saying. I want to touch Nick's point, as he was saying, safety class, boring topics. I think you really need to focus on how to present it when it's safety. Yes, knowing the details, being the expert in all the different worlds, so to say, but it needs to be presented in a way where we say we should not be scared. We have to have respect, yes, because if you're scared, you might doing something. If you have respect and you have the knowledge, you do the right thing. So I like that point that Nick was touching. It needs to be presented in that way to hopefully then result into good operations once such critical things happen.
And I would like to wrap it up, Elizabeth, by saying some comment that you made a little while ago. Everyone's made excellent points. All of the interdisciplinary engineering, all the interdisciplinary social interfaces to fire departments and so on and so forth. But one that we haven't touched upon right now is the media. One of the things about battery technology today, it's a brand new technology, it's emerging. But in reality, if you look at the total number of electric vehicle fires per unit built versus that of internal combustion engines, we have over 250,000 fires a year in gasoline-powered cars in the United States. In battery-powered vehicles, it's much less on a percentage basis than what you see in internal combustion engines. So the newer technologies always get a lot of attention from the media. And one of the things that's important to me is that we teach and train our young engineers, our young commercial people, all of our writers that are writing articles about batteries, that the technology has been proven to be extraordinarily safe compared to that of internal combustion engines, and that we don't need to be afraid of these systems if we handle them properly through proper education and training, like our other speakers have talked about. And one of the things that I find is you get older in your career and you're kind of wrapping up and ready to retire, is that you really don't care what you say anymore, because nobody can really penetrate the armor that you wear. And I'm one of those guys that like to tell people the way it is. And the way it is right now is electric vehicles are being built extraordinarily safe. They're very effective. Energy storage systems are being built very effectively and very safe systems. Now, we will have outliers where things happen. We don't know what the root cause are in some cases, but clearly with the great engineering and education and training that we give our workforce today, we're building some wonderful systems, and they're valuing mankind by reducing the amount of overall environmental pollution that we have, which is one of the end games of this technology we call electrification. So I'm very privileged and proud to be a part of that movement that we do call electrification, but it does have to be measured, and measured in a response to whatever the social needs are of the societies around the world. So I think that's a really important point, and I really appreciate the other speakers and their comments about the interdisciplinary stuff. And I wanted to touch some of the soft side as we touch society, as we touch governments around the world, because it is a necessary part of the evolutionary process of mankind.
Wonderful. Thank you. You put a perfect little bow on our discussion here today, Bob. I really appreciate that. This has been a wonderful, very insightful discussion just surrounding safety and innovation in the full battery manufacturing process. As always, the AMP Center and myself thank you for your continued support. And for our listeners out there, please be on the lookout for our upcoming webinar episodes. If you have any questions at all, please feel free to reach out to myself at empettitt@ua.edu or the AMP Center at ampcenter@ua.edu. Thank you, everyone. Have a great rest of your day.